Greetings, another video. This one is on lesson 7, practice problem 15. So solve each of the exponential equations given here we're solving them at first for x using just our logarithm techniques, and then after we get done with that, we're going to go ahead and do them graphically and then check them numerically, okay? So what we're going to do here is we're going to give the logarithm base 10 of both sides. You could have done logarithm base 2 if you would have liked to, but then you would ended up having to use the change of base theorem. So we'll just cut that and go straight to using our property of logs here that says I can bring that x out front, and that's completely equivalent to what ends up happening if you use change of base. Okay, I'm going to divide both sides now by log of 2 because that is just a number, and we get x is equal to log of 12 divided by log of 2. Okay, so how do we go about validating that from a graphical standpoint? So let's get the calculator back over here. Okay, so we go into our y equals menu, clear out whatever craziness you've got in y1 and y2, and you're going to put the original function 2 to the x, that's going into y1, and then the left-hand side, the left-hand side of the original equation goes into y1, and the right-hand side of the original equation goes into y2. Okay, now if you try doing a zoom and a standard here, it's not going to do you a lot of good because we know the horizontal line y equals 12 is our second equation. That's y2. So we're going to need to set our window here so that our y max will be somewhere around, let's make it 15. I think that's going to work really good. So x min negative 10, x max 10, y min negative 10, y max 15. Press graph. And aha, voila, we see that we have a nice point of intersection in the view screen, which means we can use the calc menu. Second calc. Go to option number 5 for intersect. We're going to go to first curve, we're going to go to second curve, we're going to go to best guess. In other words, hit enter 3 times, and we get the intersection is at 3.5849625 if you want to write it all the way out there. Okay, so we need to give a reasonable sketch of this in the viewing screen right here. So what did we see? I saw an exponential that got hit by a horizontal line, and that appeared to be at about 3.5849625. Okay, now you could have rounded that off to like 3.85 and that would have been 5, but I'll give as many places of accuracy as we've got on the calculator. And be sure and put an x and a y in there so you know which one is the x-axis and which one's the horizontal line. Okay, so they want us to also validate that numerically, and what that means is we've got to go back in and we got to check and see what log of 12 divided by log of 2 looks like. So in other words, did we get the same answer algebraically as we did when we actually went through and did the work? So we're going to take log of 12, the work being the graphical part, divided by log of 2. Yeah, looks like the same answer to me, so that checks, okay? So we got the same answer here as we got here, okay? All right, let's do this on part B here. So we've got log of 1.23 raised to the x power is equal to the log of 27. So bring that x out front, and we get log of 1.23 is equal to the log of 27, and then divide both sides by log of 1.23, and we get x is equal to log of 27 divided by log of 1.23. Okay, cool. All right, so this is a very similar problem to the last one we did. It's still going to be an increasing exponential because our base was bigger than 1. But let's go ahead and clear out that nonsense from the last problem and put in 1.23 raised to the x into y1. And in y2, we're going to put in 27, which tells me, again, I got to come in here and adjust my window. 15 is not going to cut it this time. I'm going to need to go to about 30 because I got to get above 27, which is where my horizontal line given by y2 is going to be. So let's press graph. You say, ooh, Not quite, Mikey. Looks like you also need to get some more x max in there, okay? So that was good, but not good enough. So let's make x max out to 25, just so that we make sure we got enough there. Yep, think that's going to work. Okay, so we're going to make a reasonable copy of that over here in just a minute, but let's go do the intersection routine first. First curve, second curve, best guess. And it appears that an x is equal to approximately 15.9208. Okay, so make a reasonable copy of what you're seeing on your view screen. Copy that point over here. We really only need to put the x value down, okay? If you want to put the order pair in there, that's awesome. I would appreciate if you did that, but if you just gave me the x value, like I'm doing on this kind of hacked out version here, that's fine too. So we get what? 15.921, let's say. Okay, so let's check that on the calculator in terms of numerical to see if we got, when we evaluate the function, excuse me, the expression that we got on the right hand side there, does that turn out to be about 15.921? So let's see. So we got log of 27 divided by log of 1.23. Yep, check-a-rooney, about the same, okay? All right, now get a little more complicated. We have to do some arithmetic first before we apply the logarithm. Before you apply the logarithm, you have to isolate the exponential first. So if we divide both sides by 5 here, we get 4 to the x is equal to 5. And now we'll take the logarithm, and so that's going to get me x log of 4 is equal to log of 5. And I'll let you fill in the steps, and I'm kind of going a little faster now. I know you can do it. I have faith in you. All right. So let's go see if that worked from a graphical standpoint. Let's go to our y equals, clear out y1, clear out y2, and in y1 we're going to put 5 parentheses 4 raised to the x power, and then in y2 we're going to put in 25. Let's go check our window settings. I think we're pretty good because we've got y max set to 30, so let's hit our graph here. It might have been good to kind of shrink up our x-axis a little bit. Let's do that. It's going to make it a little easier when we actually copy this down. Let's go to 10 again on the x-axis. Get easier to see that point of intersection. Yep, there it is. Okay, so second calc, number 5, first curve, second curve, best guess. And we get 1.609. Now, just as an aside, for you folks that are using the iPhone emulator, it's got a touch screen. You just have to touch the point of intersection and it'll find it for you. Just put your finger on there and move it around until you see the crosshairs go red, and then that's the point of intersection, okay? So let's come in here and draw ourselves a beautiful representation. That was not so beautiful. Let's try that again. A beautiful representation of what is on our calculator screen, which looks something like this. That point of intersection right there, there's our x, there's our y, and we see that it's about 1.161. That's approximately what we got. So let's take a look from the arithmetic standpoint. Excuse me, I got interrupted there by my software telling me that the last video is ready to be posted. Okay, so let's go second, quit, and get out of here. Try that again. Second, quit. There we go. Awesome. Okay, and so we're going to go what? Log of 5 divided by log of 4. And sure enough, we got the same numerical approximation. Okay, so I'm going to just do the algebraic part here, and then I'll let you take care of the graphical in this last one. So make sure you're going to put this in y1 and that in y2. So if we subtract 4 from both sides, we get 3 to the x is equal to 4, which gets me logarithm of 3, x times that is equal to logarithm of 4, which says x is equal to log of 4 divided by log of 3. Okay, so I'm going to say sayonara on this one, and we'll be back for another one really quick.